Hello guys, today I am going to explain you about the topic data preprocessing. So those who are going to watch for the first time, please like, share and subscribe my channel. And if you want any further other topics, please let me know in the comment section. So let's go into the topic now. That is the data preprocessing. See, what is meant by data pre-processing first? What type of tasks are there? And how the data cleaning has to be performed? What is meant by data integration? What is meant by data reduction? What is meant by data transformation and discretization? See, all these things we will see in the today's lecture. Next one is why to pre-process the data. This is one of the important question here. Why to pre-process the data means it will completely depends upon the data quality. Why? Because whatever the data you are going to get from the uh, different sources, all these data may not be accurate sometimes and it may not be complete. So we can't say that all the fields will be filled here and all the fields will not be filled here, so it will not be complete sometimes, and we can't say that it is the entire data will be consistent throughout your given, that means through the entire data modules or the data sets. We can't say that the entire data sets are completely consistent. And we will see what is the timeliness of the data. That means from time to time the data will be updated or not. So what is meant by the believability? How trustable your data is, how much correctness is there for your data, and how we can interpret our data in a very easy manner, how I can understood that particular data. Because of all these factors, we have to pre-process the data first before doing any sort of analysis. See, I want only the um, I will say one example, like suppose if I'm having one Amazon company. So we are having the Amazon is there. So what I will do, this Amazon, they need only the top 10 customers for the given product like mobiles. So what I will do, first I have to do some analysis whether the entire data is correct or not, any missing fields are there, any missing values are there, all the customers data is there or not, and all the products data is there or not. I will check in all the multiple perspectives and then I will go for the analysis. If my entire data set is correct, then only I will go for the data analysis. So that's why the first step in any uh, process is data pre-processing here. Next one is what are the major tasks in the data pre-processing. So for doing this data pre-processing, what type of tasks we need to perform. So here we are having the four techniques are there. What are those four techniques means? First one is the data cleaning. Data cleaning means it is nothing but fill in the missing values. I have to fill, if my data set is consisting of some missing values, means I have to fill some missing values, and I have to smooth the noisy data, and I have to identify and remove the outliers in my data. Outlier means nothing but the data point which will behave in some abnormal manner, not in some regular manner. It will behave in some inconsistent way. Such type of data points are called as the outliers. So I have to remove such type of outliers in my given data set, and I have to resolve the inconsistencies in my data, if any, in my data sets. And next one is the data integration. What is meant by the data integration? So integrating the data from the multiple sources. What are those multiple sources here? See, I can upload or I can extract my data from the Amazon Redshift, or else I can get my data from the Google BigQuery, or else I can get my data from the Teradata, or else I can get from the normal simple CSV files, or else I can get my data from the normal Excel files. So all these are the multiple sources of the data, but still what I can do, I can download and I can extract all these data files and I can make it into some common format. That is called as the data integration. And next one is the data reduction. What is meant by the data reduction? So different techniques are there in reducing your data here. So one is the dimensionality reduction, one is numerosity reduction, and one is the data compression. So if any huge or a very big file is there in your data sets, what you will do? Generally, we will try to compress that file and we will send it to the, or we will share it to the other persons, right? So here also we are having the other techniques are there like dimensionality reduction and the numerosity reduction. We will see these three techniques in the data reduction. And the last step is the data transformation and the data discretization. So here data transformations means I can do many number of transformation techniques on my data. What is meant by transformation techniques means? See, I can do lot of things on my data here. See, I can add one header columns or I can remove some header columns. I can add some new extra columns to my data. I can remove the columns whatever I want. I can perform whatever the actions I want. I can do the summation on my data, or else I can perform the average calculations, ranking calculations. I can get the top 10 products. I can get the top 10 customers. So all these things I can do it. These type of actions that is performed by the user are called as the data transformations and data discretization. So what is meant by data discretization means I can do the normalization on my data. How the normalization can be performed, what are the techniques in the normalization, we will see in the next slides. And what is meant by concept hierarchy generation cycle. See, these are the major tasks in the data pre-processing. These are the major tasks in the pre-processing. And the next one, see if you see this particular diagram, see this is my data cleaning. So I'm having all these bubbles are nothing but my inconsistent data, my noisy data, my error data. So what I will do, my dirty data. So I'm going to remove all these things. Any noise is there, any outliers is there. So all these things I'm going to remove, and this is my fresh and the cleaned data. This is my cleaned data. So on this cleaned data, only we have to perform the number of various operations by the user. Then only we are going to get the good results. What is the next step? See, this is the data integration. What is meant by the data integration? I can take the data from my databases, normal SQL databases or SQL Server databases or Oracle databases. I can take it from anywhere. And this is my multiple cube. From the cube also I can get my data, or else I can say it like from the data warehouse also I can get my data. And this is the normal CSV or the normal text file. So from all these multiple sources, I am going to retrieve the data and I am going to take my, and I am going to store in one place, that is called as the data integration. Collecting the data from the multiple sources and storing it at one single repository is called as the data integration. Next one is the data reduction. So what is meant by the data reduction? I am trying to reduce my number of rows and number of columns in my data set. See here, if you observe it here, I am having the lot of attributes are there like A1, A2, A3, and here till A126 columns are there. And here, if you see the transactions here from T1 to T, 2000 transactions are there. So what I am going to do, see, I am going to reduce my data here from A1 to A115. So here the reduction of the data sets will be there in terms of the row reduction and the column reduction. And here, if you see the particular transactions here I am having the 2000 columns are there. But here I have taken only the T 1456 columns only here. So this type of reduction, attribute reduction, we can do it here. If any irrelevant rows and columns are there, simply we can remove it and we can do the analysis part here. See here, this is the data transformation. See how my data is here. I am having the negative values are there. I am having the positive values are there. So I can represent with the help of in the another decimal format also I can represent my data. So how I will get my decimal format data here means if I divide it with 1000, automatically I will get my this decimal format data. This is called as one type of transformation technique. I can say it like a transformation technique which is performed on the given data values. So this entire tasks we are going to call it as the data pre-processing steps. Next one is the data cleaning. What is meant by the data cleaning? See, let's see here. We are having the real world data will be there. In the real world, don't think that only few 10 columns or 20 columns will be there in our data. So the real world data, if you take like Amazon or Flipkart or Netflix or whatever it may be, the data will be of very huge size. So if you want to do some analysis on that particular data also, it will take lot of time, and we have to analyze many things on the rows and the columns. So here the data will be completely incomplete, and noisy data will be there and inconsistent data will be there in the data cleaning process. So here data cleaning, it will try to fill in the missing values, and if any smoothing, if any noisy data is there, we have to smooth out the noisy data while identifying any outliers and the inconsistencies are there in your data. So this entire process is called as the data cleaning process. So here we will see what are the missing values we are having. Suppose if I am having any missing values are there, what I will do here. So first step in the missing values is here. First one is ignoring the tuple here. So what is that? Ignoring the tuple here. Ignoring the tuple means, see here, this is usually done when the class label is missing. So if any class label is missing means what I will do if I don't know anything about that class label means simply I can ignore that particular tuple. This is one technique here for the missing values. So that means if my data consisting of the missing values means how to fill in that missing values here. So filling the missing values manually. So next technique is I can fill in the missing values manually. So manually with the help of the people, I will try to make it enter all the values here. But suppose if I am having a very large data sets are there, it is very difficult in filling the values manually here. And third important step is use a global constant to fill in the missing values. What type of global constants I can use it here for replacing the missing values means here I can use the labels like uh, infinity or unknown symbols here. So if any missing values are replaced means we can if any missing values are replaced means we can replace it with the unknown, or else I can use some constant value like infinity symbols. I can use it if you want to fill it with the any global constant means I can use it any of these things, whether unknown I can use it or I can use the infinity symbols also. And next one is using the attribute mean value to fill in the missing values. What is this attribute mean value means? See here, suppose if I am having the average income of the all electronics customer is the $56,000 is there. So what I will do using this value to replace the missing value for the income. So I'm having the average income of the electronic customers in the 15,000. I came to know that that is the average income of the customers. So what I will do if any missing values are there, I will replace with this mean value in the missing values places. So if any income column is there means if any values are missed in that particular column means just I will replace it with the mean value of that particular store, electronic store. Use the attribute mean for all the samples belonging to the same class as the given tuple. And the next technique is use the most probable value here. Using the most probable value to fill in the missing values. So what are those probable values? Just it can be determined with the help of the regression or inference based tools using the Bayesian formalism, or by using the decision tree induction. Or by using the decision tree induction also we can do the using the most probable values also we can fill in the missing data. And next one is the noisy data. How to remove the noisy data? What is meant by noise first of all? So noise means any dirty data or any random data with some errors or with some variance in the measured values can be treated as the noisy data here. But here we can smooth out this particular noisy data here by removing the noise. So we are having few data smoothing techniques are there. What are those data smoothing techniques? This is one of the important techniques in handling the noisy data. See, suppose if I'm having these data values are there like 4, 8, 15, 21, 20. This is my data values are there. So if I want to smooth out if I have to perform the smoothing techniques on this noisy data means, first step is first we have to partition into the equal frequency bins. Next one is smoothing by bin means, and third one is the smoothing by bin boundaries here. So what is that one? Partitioning into the equal frequency bins. What is meant by partitioning into the equal frequency bins here? So here, if I want to partition into the three bins here, I have taken the bin size as 3 and I am going to divide into the bin 1, bin 2 and the bin 3. Three different bins I am going to divide it, and three values I am going to keep it in each and every bin here. So this is called as a partitioning the data into the equal frequency bins. Next one is the smoothing by the bin means. Bin means this is my first bin value. What I will do here, I will calculate the mean value for this given bin, and that I am going to replace it with all the values of the bin here. So what is the bin 1 value here? So here let's take the example of the 4 plus, I will get 4 plus 8 plus 15 by 3 I will take. 15 by 3 means how much values I will get here, ma? So here 12 plus 15, 27, 27 by 3. So here 27 by 3 means we will get the value 9. So I am going to replace this 9 value with the bin 1. with the entire bin 1, I am going to replace the values. In the same way, I have to calculate for the bin 2 and then bin 3. So what value I got for the bin 2? I got the 22. So I have replaced it with the 22. And here I got the value like 29 and I have replaced it with the 29 here. This is nothing but smoothing by the bin means. Next one is the smoothing by the bin boundaries here. So smoothing by the bin boundaries means here, see if you observe here, I'm having the two values are there. One is the minimum boundary and one is the maximum boundary. What is meant by the minimum boundary here? Minimum boundary is the value 4 and maximum boundary is the value 15 here. So what I will do here, I'm going to replace it with the minimum values and the maximum values here. Suppose if you take the first value, this is my minimum value. So I have written in the same way. Next 8 is nearer to the minimum value. So I have written it with the minimum values only. And 15 as it is, I have written it like the maximum value. Next to 21, 21 and 24 are there. What is the minimum value here in the bit 2? 21 is the minimum value and 24 is the maximum value. So for the 21, 21 is the minimum value and next again 21 is the minimum value and again 24 is the maximum value. Next, if you take the 25, 28 and 34 among these three values again, 25 is the minimum value and 34 is the maximum value here. So here 25 I have written as it is and if you take the 28 again, and again, for the 28, again I am going to write with the 25. Why? Because 28 is nearer to the 25. So I have replaced it with the 25. And here again I am going to replace it with the 34 as it is I am going to write. So here smoothing techniques are three types. One is with the help of the equal frequency sized bins. Second one is the bin means and third one is the bin boundaries. So I hope you like this video guys. Thank you for watching this video. Please like, share and subscribe this video if you like this particular topic.